Good morning, my dear students. My name is Dr. KCH Apparao, working as an associate professor in mechanical department, Institute of Aeronautical Engineering, Hyderabad. Okay, in previous classes we discussed the numericals on forced convection. You know that convection is two types. One is the natural convection and the forced convection. We saw in previous classes the how to find the rate of uh, heat transfer coefficient in forced convection. Forced convection. You know that because convection is completely associated with the bulk movement of the particles from one place to another place. Okay, so heat transfer takes place by bulk movement of the particles. So uh, in fluids, okay, in the bulk movement of the particles, there are so many physical properties of the fluid should be uh, considered those parameters because those parameters influence the heat transfer coefficient H. So to find the H, just like how to consider the all the physical properties of the fluids. So we already derived the how to find H. So because in forced convection, so we have to find out the Reynolds number and the Prandtl number. So the relationship Nusselt formula is the combination of Reynolds number C into Reynolds number to the power of n into Prandtl number to the power of m. So Cnm is the constants is depend upon the uh, geometrical construction of the solid surfaces. It means in which uh, medium just like fluid flows, either fluid flows in the solid surface, that is the outer flow, or fluid flow in the inner tube, that is the inner flow. So based upon the flow, just like C and M values is depend upon the geometries. So you know that Nusselt formula. Then by using the Nusselt formula, you can find that H value, H is equal to, because Nusselt is equal to HL by K. So by using this formula, you can find out the H value. So this is the process already we discussed in previous classes. Okay. So now we'll see the just like natural convection. We'll see the problems on the natural convection. How to find the H value in natural convection. After that, how to find the rate of heat transfer HA into temperature difference. Okay. So finding H is very important because this H is associated with the so many physical properties of the fluid. You know that one. So we'll see how to find this H in natural convection. Okay. So first of all, you know that once again I want to remind the natural convection process. Okay, convection takes place by the movement of bulk movement of the particles from one place to another place. This movement of the particles takes by naturally by some external agent. If it is the flow movement or the movement of the particles uh, take by some external agents that shows the forced convection. If the movement of the particles from bottom to top occurs randomly, naturally, so that is called natural convection because uh, that occurs by the effect of the buoyancy. You know that it means density differences. Okay, so it means if you take the container, if you heat the water, so initially the surface, bottom surface of this container will be heated. Then the particle which are near to the surface, so heat transfer from the solid to that near particles. Then the particles which are heated, so the density of the particles will be decreases, and the less density particles moves into upward direction, and a heavy density particle flows into downward direction. So in this way, heat transfer takes place from the bottom to top. Okay, so this is occurs by naturally. by the effect of density differences, by the effect of buoyancy. So it is called natural convection. I know that PV is equal to nRT, the universal formula nRT. Okay, just like then P is equal to N by V into RT. So N by V is nothing but density. So P is equal to rho into RT. So then rho is equal to P by RT. So R is the constant. You know that if you consider pressure also just like constant, if you take that one, then rho density indirectly proportional to the temperature. If the temperature increases, automatically density decreases. So based upon this principle, the particles moves, the less density particles moves to upward direction, heavy density particles moves into downward direction. So this is the natural convection process. So in which mm, fluid flows or particles moves from bottom to top occurs naturally by the effect of buoyancy. Okay, we'll see few points regarding the natural convection. So in the case of natural convection, so heat transfer is due to molecules which gain low velocity. So due to density differences between the molecules near the solid and wall and the surrounding. It means natural convection occurs by just like because of density differences. What was already explained that one. So in the free convection, so no external agent is required to move the particles, to move the bulk movement of the particles. Okay. So you know that external agent like pipe and fan. So if we use the pipe and fan, so that is the forced convection, not a free convection or natural convection. So without any external agency, external parts, so movement of the particles will be occurred. So due to density difference. So that process called the free convection. Okay. So because the motion takes place due to the buoyant action or buoyancy force. Okay, you know that. Okay, so in natural convection heat transfer, the flow is classified as two types. So you know that two types of flows. One is the laminar flow and turbulent flow. So already discussed in previous classes that the type of flow or laminar or turbulent is identified by the Reynolds number in forced convection. In the similar way, just like in natural convection, so identification of the laminar and turbulent flow is based upon the dimensional number that is called Grashof number. Okay, so Grashof number. So what what role Reynolds number? So what type of role plays the Reynolds number in forced convection? The same role so will be played by Grashof number in natural convection. So that is very important. It means in forced convection we will consider the Reynolds number. In natural convection we consider the Grashof number. So Reynolds number is associated with the velocity UL or UX, UL by nu viscous forces and the velocity forces just like UL. So velocity, if the velocity is given, that is related to forced convection because so velocity of the particles or a fluid occurs by uh, using some external agents just like pipe and fan. If the velocity is given, so simply you can consider that one, that flow is the forced convection. If the velocity is not given, so without velocity, if the flow, it means uh, the fluid particles are moving from one place to another place, means that is by effect of the buoyancy. So that is called natural convection. So for the natural convection, we consider the only Grashof number. We'll see what is the Grashof number. Grashof number is nothing but just the ratio of buoyancy force and viscous force. Buoyancy force and viscous force. We will see that one. Before going to that, we will see the just boundary layer in the natural convection. So this is the solid plate. The fluid is like this one. So heat just this one is the fluid. Heat transfer takes place from the solid to fluid, surrounding fluid. So because T wall temperature is greater than the bulk temperature of the fluid. Okay. So heat transfer takes place. So this shows the thermal boundary graph. So temperature, so at the solid surface is high. So gradually temperature increases. So this portion, it means here temperature is equal to nearly equal to bulk temperature of the uh, it means so fluid temperature near equal to fluid temperature. So but velocity graph you can identify the velocity graph is so in near of the solid surface the velocity is 0. It gradually increases at one position. It reaches the maximum point. Again it will the velocity of the fluid is decreases. Okay. So the velocity profile graph is like this one. In solid surface velocity profile graph is in, it means in forced convection velocity profile graph is you already study that one. Okay. But here in natural convection velocity profile is like this one. Initially increases. So at one point it will reach us to maximum point, then automatically decreases. So here, so it means at solid surface velocity is no velocity. So in after some distance, just like here, some particular distance, just like velocity is equal also 0. So at particular point, velocity reaches the maximum point. So you can identify that one. So next one, natural convection. You know that too. So the particle which are very near to solid surface, heated surface. So heat takes from the solid surface to uh, surrounding particles. When the particles taken the heat from the solid surface, so automatically the particles density of those particles will be decreases. So because density is the indirect proportional temperature. Okay. The less density particles moves in upward direction because of buoyancy force, but some frictional force it opposes the in downward direction. So here buoyancy force is greater than the frictional force. Automatically the fluid particles, less density particles comes into upward direction. But cold fluid, so so here for the cold fluid, frictional force is greater than the buoyancy force. So the heavy particles moves into downward direction. So based upon this principle, just like natural convection works. So now we'll see the Grashof number. So GR it is represented by GR. So it is very important to dimensional number in natural convection, similar to Reynolds number in forced convection. So Grashof number is equal to buoyancy force by viscous force. Okay. So buoyancy force is nothing but beta or g acceleration due to gravity, beta the coefficient of volume expansion. So beta is nothing but, so this beta is nothing but 1 by t mean. What is t mean? So t mean you already know that solid surface temperature plus uh, fluid temperature. So T infinity by 2 or a TW by 2. Okay. So this is the T mean. 1 by T means, so that is the coefficient of volume expansion. So next delta T. So temperature difference, temperature of the solid surface minus temperature of the fluid. So next LC the characteristic length. You know that that parameter we already saw that type of characteristic length in forced convection also. So LC is very important, characteristic length. So divided by so nu, so viscous kinematic viscosity nu square. So this is the formula for the um, Grashof number. Okay. So it is this the ratio of the buoyant force by viscous force. Okay. So for the heated particles, buoyant force is greater than the viscous force. For the cold fluid, viscous force is greater than the buoyant force. Okay. So you know that the heat is increases, viscosity will be decreased. Okay. So we'll see the characteristic length. It is depend upon the geometry of the just uh, pipe. So the pipe are a solid surface. So on which plate, on which surface the fluid flows. So we'll see. So here three types of geometrical construction you can see. So if the flow is passing through the vertical cylinder or plate or vertical cylinder. So in this case, characteristic length LC is nothing but the length of this plate or height of the cylinder. Okay. So here in this case LC is equal to for the rectangular plate. So length will be characteristic length. For the vertical cylinder, height will be characteristic length because the vertical distance is important here because the particles moves from the so bottom to top. So less density particles moves upward direction, heavy density particles moves into downward direction. So we have to consider the height. Okay. So that is one case. Another case, if the flow is flowing through the horizontal pipe like this one, horizontal pipe. Okay. Here also we have to take the uh, characteristic length means so diameter of the pipe. So LC is equal to diameter of the pipe. How to consider this one? Not length of the pipe. So diameter of the pipe. So always we'll see the particles moves from bottom to top. So in case of natural, so bottom to top we will consider. In the forced convection, just left side to right side, just like flow started point to ending point. So that one. Next to horizontal plate. So if you consider the horizontal plate like this one, horizontal plate, flow on a horizontal plate. So then characteristic length LC is equal to uh, area upon the perimeter. So by using this formula, you can find out the characteristic length. So the three types of the geometrical constructions based upon the these constructions, we have to take the characteristic length. Okay? So that is very important. Okay. So next, identification of the flow, either laminar and turbulent flow. So in forced convection, we saw that it is identified by the product of just like multiplication of Reynolds number and Prandtl number. Okay, if it is this product, no, only Reynolds number. Okay, so the it is based upon the Reynolds value. The Reynolds value is greater than the 5 into 10 to the power of 5. So that is the turbulent flow. Less than 5 into 10 to the power of 5. That is the uh, laminar flow. So in forced convection, here there is no Reynolds number. So you have to take the Grashof number. So you have to take the product of Grashof number. So that product of Grashof number is simply called as uh, Rayleigh, Rayleigh number. Rayleigh's number. RA. It is represented. Not RE. This is RA. So RA is nothing but Grashof number into Prandtl number. So this value should be less than 10 to the power of 9. So this value is less than 10 to the power of 9. So that shows the laminar flow. If the product of GR and PR is greater than the 10 to the power of 9, So it means greater than the 10 to the power of 9. So GRPR. So that shows the turbulent flow. So here critical uh, Rayleigh number is 10 to the power of 9. So below the 10 to the power of 9, that shows the laminar flow. So above the 10 to the power of 9, so that shows the turbulent flow. You have to remember this one. So similar same process in the what was taught in um, forced convection. You can see here also. Okay. So identification of flow is very important. Based upon the flow, you have to take the formulas. What are the different formulas derived from the different equations, momentum equations, and so energy equations. Those is already derived those formulas. Now we'll see. Okay, so just directly I am explaining some few numericals which are based on natural convection. We'll see directly. So how to solve the H value? So here a horizontal plate. So plate is horizontal position. You know that this is horizontal position. You know that characteristic length LC is equal to diameter. Okay. So diameter of the horizontal pipe is equal to 30.5 centimeters. Convert into meters. It means LC is equal to diameter is equal to uh, so 30.5 centimeters, 0.305 meters. So that is the characteristic length. So is maintained at a temperature. So horizontal pipe temperature. So that is 250 degrees centigrade. So it is the it means so hot body is the solid surface, and the air. So ambient air is at 20 degrees. So surrounding air. So it means heat transfer takes place from the horizontal mm, pipe to surrounding area. So surrounding air. So ambient temperature. It means so T solid is equal to 250 degrees Celsius. T uh, ambient temperature T infinity is equal to 20 degrees Celsius. Okay. If you know the two temperature, you can find out the T mean also. T mean is equal to Ts plus T infinity by 2. It means so 50 plus 20, 55 plus 20. No, no. 250 plus 20, 270 by 2. Okay. It is 135. So at 135 degree Celsius, the temperature of the air. So you have to take the properties. Okay. So with respect to temperature, air properties at 135 degrees Celsius. Okay. So these are the properties here given already. Thermal conductivity of the air is equal to 0.0234 watt per meter degree Celsius, and Prandtl number PR is equal to 0.63. So you can take these properties from the data book. So properties of the ambient air, okay, dry air. So at 135 degree Celsius. Okay. So new kinematic viscosity is equal to 26.25 into 10 to the power of 6, 10 to the power of minus 6 meter square per second. So these are the values, properties. The properties are given in the numerical. Okay. Otherwise, you have to take the properties. You have to identify the properties from the data book with respect to. So properties of the air at 135 degrees Celsius. It means T mean value. Okay. Okay, you know that. So we have the properties of this one. Then automatically you have to identify which type of flow. So because this is the laminar flow, because velocity is not given. So you can consider this one as the uh, natural convection flow. Okay. So then we can find out the which type of flow. So it means uh, either it is laminar flow, turbulent flow. What type of flow? We have to identify that one. So this type of flow is depend upon the that GR into PR Rayleigh number. So you have to find out the GR. So what is the formula for the GR? You know that G acceleration due to gravity, beta exponential constant into delta T temperature difference into characteristic length square uh, Q by kinematic viscosity square. So this is the formula. You know that G is the constant 9.81 meter per second square. You know that beta is the so 1 by T mean 135. So delta T is the just like 250 minus 20, and LC is the diameter, that is the 0.305 LC cube. This one by one more thing, just like so I forget that one. So beta is equal to, remember this one, beta value. So beta is equal to 1 by T mean plus 273. That should be, must be converted into kelvins. Okay, so it is in degree Celsius. So it is in, so if you add this 273, that will be in kelvins. So 135 plus 273, how to add this one, that is the 408, that value. Okay, so if you just like solve this one, so gross up number, then we will get the value, that is the value is equal to 2.27 into 10 to the power of 8. So this value is less than the 10 to the power of 9. So Rayleigh number is less than the 10 to the power of 9. So it means it is a laminar flow. Okay. So laminar flow, different formulas are there. So based upon the, by using the data book, we can choose the formulas. Choose the formulas. So based upon the laminar flow, based upon the type of the uh, pipe, either it is the horizontal pipe or the vertical pipe, either it is the solid surface or the vertical surface. So based upon these construction geometrical so positions, just like we can choose the different formulas. So different formulas are there. That is the Nusselt value is equal to C into GR and PR to the power of n. Okay, so the C and N is depend upon the position of the pipes, position of horizontal pipe, either it is horizontal portion or the vertical portion, solid surface vertical portion, horizontal portion, any other geometries. Based upon the position, C and N values will be changes. So these C and N values and these formulas will be taken from the data book based upon the numerical. Okay, construction of pipes or position of the pipe. Okay, here just like, so you can see this just like in page number 146 in data book. So we'll get this formula which is related to this numerical. So Nusselt is equal to C into GRPR to the power of n. This is the common formula. So for the horizontal pipe, so this is the just like formula. So that is the formula is equal to Nusselt is equal to 0.125 into so GRPR to the power of 0.33. So 1 by 3. Okay, this is the formula you can take from the data book. So, so based upon data book, you can choose this one. So you can refer that one in page number 146. Okay. So okay. So then Nusselt is equal to 0.125 into gross up number Prandtl number value. You already solved that one. 2.27 into 10 to the power of 8 and whole to the power of 0.333. Okay. So if you solve this one, you will get the Nusselt formula. Nusselt is equal to 66.7. Okay. So if you got the Nusselt, then you know that Nusselt formula is equal to HL by Q. L means here LC, characteristic length. Okay. Then you can find out the H value. H is equal to Nusselt into um, thermal conductivity of the uh, dry air by LC. Okay. So Nusselt value is equal to 66.7 into thermal conductivity K, and the value of K is equal to so 0.2 something mistake there. Okay, 0.0234. You can see here thermal conductivity K is equal to 0.0235. Okay, divided by castic length LC. LC is nothing but diameter. So diameter is equal to 0.305. So here you can write the 0.305. Okay. If you solve this one, just like we'll get this one, H is equal to 5.11. Okay. If you know the H, then automatically you can find out the rate of heat transfer. You know the formula, Q is equal to HA into T solid minus T fluid. It means dry air. So you know the H value, that is the 5.11 into area. So area is equal to just like you know that area of the solid surface, horizontal surface. So that is the so this one is the perimeter, the pi d into length of this pipe, because it is in horizontal portion. So that is the L. Okay. So if you substitute the values, so diameter, pi d, and the length also given. If you solve, if you just like substitute the values and the H value also, you will get the final value. That is the rate of heat transfer. That is 1127.8 watts. So okay, in this way, just like we can solve the numericals. You'll see one more numerical. So here the pipe is in vertical position, vertical pipe. So of 10 centimeter OD. So diameter of the pipe is equal to given vertical pipe. So at a surface temperature of 100 degrees Celsius. So T solid 100 degrees Celsius. So is in a room where the air, so air temperature, that is the T infinity, is equal to 20 degrees Celsius. So the pipe is 3 meter long. So it means vertical position, length of the pipe is equal to 3 meters. Okay. So this is the diameter, 10 centimeters. It means 0.1 meters. Okay. So here just like the pipe is in vertical position, this length should be the characteristic length. Okay. Here characteristic length LC is equal to, so 3 meters. You have to consider this one. Okay. So for area, finding the area, you can consider the diameter only. Okay. So what is the rate of heat loss from 1 meter length? So it means 1 meter length means for the L. Okay. So L is equal to for 1 meter. So thermal conductivity, here fluid properties are given. Otherwise, you have to take the fluid properties from these temperatures. You know that you have to find out the T mean. Okay. T mean is equal to Ts plus T infinity by 2. So 120, it means 120 by 2 is equal to 60 degrees Celsius. So the properties of the air at 60 degrees centigrade Celsius. So you can choose the just like properties of the air. So properties of the air, thermal conductivity of the air is equal to 0.02896 watt per meter degree Celsius. Prandtl number values you can take, and kinematic viscosity, so 18.97 into 10 to the power of 6. So these are the parameters. So these properties are not given in the numerical. You have to choose by this method. You know that one. Okay. So now we'll solve the H by using this data. After H, then you can find out the rate of heat transfer. Okay. We'll solve this numerical. Listen carefully. So this is the diagram. So pipe is in vertical position. So the diameter of the pipe is equal to 10 centimeter, is nothing but 0.1 meter. So this is the height of the pipe, that is the length of the pipes, that is L is equal to 3 meters. That is nothing but characteristic length. You know that. Okay. So solid surface temperature, that is the TWR TS, solid surface temperature is equal to 100 degree Celsius. So ambient temperature, surrounding temperature is equal to T infinity is equal to 20 degrees Celsius. Okay. Then you can find out the T min. So Ts plus T infinity by 2, that is 60. So based upon this 60 degrees, you can take the properties. Otherwise, you can find out the beta. So beta is equal to 1 by 60 plus 273. So it will be converted into kelvins. Okay. So that is the value. Okay. So first of all, you have to find out the gross up number. So you know that gross up number GR is equal to uh, so beta G into delta T into LC cube by mu square. This is the formula. So beta is nothing but just like 1 by 60 plus 273. So we can add so triple three. So 1 by triple three into so G value acceleration due to gravity is equal to 9.81 into delta T temperature difference 100 minus 20, that is the 80. So into LC square, LC cube. LC is nothing but 3 meters height of the vertical pipe. So 3 cube by so kinematic viscosity, that is the 18.97 into 10 to the power of minus 6. If you solve this one, you will get the gross of value. Okay. Here just like already I have given steps of first we'll see the. So this is the formula for the gross of number to find the gross of number. So beta G into delta T L cube by so characteristic length cube by kinematic viscosity. So then so if you substitute the values, so beta G is 9.81, beta is equal to 1 by 333. So this is the value, and delta T is equal to 100 minus 20, 80. So 3 cube characteristic length cube by triple three into kinematic viscosity 18.97 into 10 to the power of minus 6 whole square. So this is the value. So if you compare this one, then you know that Prandtl number value is equal to 0.96 696. Then the product of GRPR is equal to 1.76 into 10 to the power of 11 into 0.96 696. So that the final value is equal to 1.23. So 1.23 into 10 to the power of 11 is greater than the 10 to the power of 9. So it is a turbulent flow. So not laminar flow. Okay. It is a turbulent flow. Okay. So the flow is turbulent. The pipe is in vertical position. So then you have to choose the formula for the natural convection. So based upon the by using the data book. Okay. In order to formula. So here just like same. So identify that one. This is the turbulent flow because GRPR is equal to greater than the 10 to the power of 9. Now we'll see. So this is the formula taken from the data book. So you know that Nusselt to L is equal to 0.1 into GRPR whole to the power of 0.333. Okay. So this formula is taken based upon the position of the pipe, that is means vertical pipe, natural convection. You have to consider this one natural convection. So velocity is not given, means next to vertical cylinder, that is the vertical cylinder, and GRPR range. So based upon these parameters, you can choose this formula from the data book. Okay. You can refer 144, then you can identify this formula. Okay. So Nusselt value is equal to 0.1 into GRPR value is equal to 1.23 into 10 to the power of 11 and to the power of 0.333. So the value is equal to Nusselt value is equal to 931 493.1 493.1. So then this is the just like average value. Just like we can refer in 144, just we can find the average mm, Nusselt value. For finding average Nusselt value, 5 by 4 Nusselt uh, with respect to L. It means for the bottom surfaces. So if you solve this one, automatically Nusselt value is equal to, we'll got the 616.4. Okay. So by using this one, you can have to find out the H value. Okay. So you know that formula is equal to Nusselt is equal to HL by K. So then H is equal to Nusselt into K by L, characteristic length. If you substitute this one, just like then you can find out the H value. So H value is equal to 545 watt per meter square. So this is the value. So if you know the H value, then you can find out the rate of heat transfer Q. So what is the formula for the rate of heat transfer? So the rate of heat transfer Q is equal to HA into T S minus T infinity. Okay. H is equal to, what is the value? 545 into area. Area is equal to just outer surface area into pi d into L. So pi d, d is equal to 0.1 into L is equal to 3 meters. Okay, pi d into L. So otherwise, just like we can find out the L is equal to 1 meter length. Here just uh, heat loss from 1 meter length. So we can take 1. So into Ts, that is 100 minus 20. If you solve this one, you will get the answer. So that is the just like 149.54 watts. So this way you can find out the uh, rate of heat transfer in natural convection. Okay, we'll see few more uh, numericals here. Just like a circular plate. So plate here, a circular plate. Okay, so the diameter of the circular plate type heater, that is the diameter of that one. So that is the 300 mm diameter, 0.3 meters, is insulated at one surface and maintained at uh, so one surface is insulated and another surface is free. So maintained at another surface. If you if you consider bottom surface is insulated, so heat transfer takes place from the top surface. Okay. So the temperature of the top surface is equal to 200 degrees Celsius. So it is exposed to the transient surrounding air. So surrounding air. So the air temperature is equal to T infinity is equal to 20 degrees Celsius. It means so Ts is equal to 200 degrees Celsius and T infinity is equal to 20 degrees Celsius. Okay, then you can find out the T mean. So Ts plus T infinity by 2, 200 plus 20, 220 by 2 is equal to 110 degrees Celsius. So for the dry air, so fluid is there and at 110 degrees Celsius, you have to take the properties. Okay. If you consider the properties from the data book, so we'll get the properties. Properties nothing but thermal conductivity of the fluid and uh, Prandtl value of the dry air and kinematic viscosity of the air. You see, just like this is the pipe. So here, so bottom surface is insulated. So because there is no heat transfer, so heat transfer takes place from the top. So top surface. So the temperature of that one is equal to 200 degrees Celsius, uniform wall temperature. Okay. So temperature, heat transfer takes place from top to surrounding air. So that is 20 degrees Celsius. Okay. So this is the T mean, that is 110 degrees Celsius. By using this T mean, you can take the properties of air at 110 degrees Celsius. That is the value. Thermal conductivity of the air is equal to 0.032 watt per meter Kelvin. and kinematic viscosity is equal to 24.29 into 10 to the power of minus 6 meters square per second. So Prandtl value, so that is equal to 0.687. Okay, so these are the values. So then you can find out the Grashof number. You know the formula of Grashof number. So gr is equal to g acceleration due to gravity and beta into delta t into lc cube by nu square. Okay, so you know that this is a 9.81 by 1 by 110 plus 273, 110 plus 273. So it means 383. So 383 into delta t, 200 minus 20, that is the 180 into LC. So LC is nothing but mm, so vertical height. What is vertical height? Characteristic length. Okay, you can take the ES by perimeter formula. You can apply this one. So here length is equal to ES area. Area is equal to 5 for d square into perimeter pi d. If you solve this one, characteristic length is equal to d by 4. You know that the diameter is equal to 300 mm, 0.3 meters by 4. So that is the value. You can substitute here. Okay, the value is equal to. So if you substitute all the values, you know that the Grashof number formula. If you substitute the values, then you will get the Grashof value. The final Grashof value is equal to, this is LC's value. It means so d by 4 0.075. Okay. So this is the Grashof value. Then you have to find out the product of Grashof and GR into PR. Okay. So the GR PR, you have to find that one. So here GR PR. So GR is equal to 3.29 into 10 to the power of 6 into Prandtl number. PR is equal to 0.6897. If you solve this one, automatically you will get the something 10 to the power of 4 and something. So automatically, so we can this is less than the this is less than the 10 to the power of 9. It means so we can consider this one. This is the laminar flow. So then based upon the geometrical, it means so circular pipe geometry and the laminar flow and the natural convection. So by using these parameters, you can choose the Nusselt formula from the data book. Okay, so it means natural convection process, horizontal pipe, circular horizontal pipe, uniform temperature, top surface hot. So based upon this data, you can take the Nusselt formula. So Nusselt formula is equal to 0.54 into 10 GRPR to the power of 0.25. Okay. So by using this one, if you solve this one, automatically you get the Nusselt value. If you know the Nusselt value, so Nusselt formula is equal to HL by K. Then from this formula, you can find out the H value. So H is equal to, got that one 9.13. Just I have given the direct values here. So if you know the H value, automatically you can find out the rate of heat transfer. P is equal to HA into Ts minus T infinity. Okay. So H, you know that this value, area of the pipe, you know that one. Okay. So area of the pipe means so top area pi for d square. Okay. So if you substitute these values, you will get the Q value. Q value is equal to 116.65 watt. So this is the value. So we'll see one more numerical and we conclude this one. Okay, a fine wire having a diameter. So this is the wire having a diameter is equal to 0.02 mm is maintained at a constant temperature. So temperature of the wire, that is Ts, is equal to 54 degrees Celsius. So by an electrical current, so constant temperature, the wire is exposed to air air atmosphere, the pressure is equal to 1 atma, and so temperature of the air is equal to 0 degrees Celsius. Okay. So to temperature, you know the T mean, you have to find out T mean is equal to 54 plus 0 by 2. So that is the 27 degrees Celsius. So by using this temperature, so you can take the properties of the air. So here, air properties. If you take the properties, just like 27 degrees Celsius. So that is nothing but in Kelvin, 300 Kelvin, because you have to add the 273. So then the properties are thermal conductivity of the air is equal to 0.02624, and the Prandtl value is equal to 0.708, and kinematic viscosity is equal to 15.69 into 10 to the power of minus 6. These are the properties, and you also can find out the beta. Beta is nothing but 1 by T mean, 1 by, so 27 plus 273, 300. So this is the beta value. Okay. So then you can find out the gross of n. Gross of number is equal to G into beta into delta T into LC Q by mu square. So if you substitute these values in the gross of formula, then you will get the gross of number. After you got the gross of number, you can find out the product of gross of number into Prandtl number. So to find the Rayleigh number. So to find the type of the flow, either it is flow of laminar or turbulent. You can see. So the product of gross of Prandtl, so that is the, so is equal to 9.8. This is the just like directly has written. This is the formula, gross of number formula into Prandtl number value also is taken. So the value is equal to 4.205 into 10 to the power of minus 5. Okay. So it means so it means, so this is the value. Okay. This is the value. So this is less than 10 to the power of 9. So it is the laminar flow. So then you have to take the formula, Nusselt formula. So Nusselt formula, so that is the wire. What type of wire? So a fine wire having a diameter is maintained at a constant temperature. So that is the pipe is here wire next to natural convection. Next to this is the laminar flow. So by using these just like parameters, you can choose the Nusselt formula for this one. So just like you know that Nusselt formula is equal to C into GRPR into all to the power of M. So C value and M value based upon this wire and the natural convection laminar flow. C is equal to 0.675 and M is equal to 0.058. So if you refer the data book, then you can understand this one. Okay. So then the formula, Nusselt formula is equal to C into GRPR all to the power of M. So here the GRPR is equal to Rayleigh number 4.05 into 10 to the power of 5. So the Nusselt formula, according to Nusselt formula, the Nusselt value is equal to 0.375. Then if you know the Nusselt value, you know that HL by K. So HL by K. So then you have to find out the H value. Nusselt into K by L. Okay. So here L is nothing but diameter. So diameter of the pipe, L is equal to diameter. So you know the diameter. So Nusselt value is equal to 0.375 and the thermal conductivity value is equal to this one, and the diameter 0.02 into 10 to the power of minus 3. So this is the value. If you substitute this one, they will get the H value. H is equal to 492.6 watt per meter square degree Celsius. If you know the H, then automatically you can find out the rate of heat transfer. So HA into temperature difference Ts minus T infinity. So H is equal to 492.6 into area, the area 5 for d square. Okay. So area is equal to area of the outer area of the pipe, that is not just side area, outer surface area, that is the pi dl you can take. So pi d into L is equal to 1. Okay. Pi dl. So L is equal to 0.5 as given already into temperature difference. So temperature difference is equal to Ts minus T infinity. So if you substitute all the values pi d into L here, you will get the just like heat flux, rate of heat transfer Q. The rate of heat transfer Q is equal to 0.839 watts. 836 watts. So this is the value. So in this way, just like you can solve the numericals. So the similar manner, just like in forced convection, you have taken the Reynolds number for the identification of the uh, flows. Either it is laminar flow, turbulent flow. In natural convection, just you have taken the Grashof number. Okay, so it means forced convection Reynolds number is important. Natural convection Grashof number is important. Okay? GR. So by using the in forced convection Reynolds value. So based upon the Reynolds value, you have to identify the type of flow. In the natural convection, product of Reynolds GR and PR, that is Rayleigh number RF. So based upon the value of the Rayleigh, you can identify the type of flow. Okay. If you know the type of flow and the type of convection process, either a natural or forced convection, then you can find out the uh, just like Nusselt formulas. So based upon those parameters by using the data book. So in this way, you can find out the different numericals based upon on in natural convection. Okay. Thank you for listening to class. We will see further numericals in next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.